Hey everybody, Mr. Fraser here from NeonMaths. This is my second video on solving linear equations. In the first video, we looked at solving simple linear equations, one-step and two-step linear equations. Today we're going to be looking at taking a little bit further. How do we solve linear equations with unknowns on both sides? And how do we solve linear equations that involve brackets? Stay tuned to find out.
Fractions when they come up with the root sign down. Lethal weapon in your mind, like a gun without a sound. No shortcut, no mark scheme, quit your chattering. It's your discipline, lets you stay true to your regimen.
Sometimes we get cases where the unknown value appears on both sides of the equation. In order to solve these types of equations, we just need to be systematic. We need to get all of the numbers on one side of the equation and everything with an unknown, with a variable, on the other side of the equation. Remember, in order for us to solve it, we need one of the unknown equal to another number. For example, so as you can see in this equation, we've got unknowns, in this case x's, on both sides of our equation, and we've got constants, or our numbers, on both sides of the equation as well. Now, in order to solve this, all we need to do is be systematic. We need to get all of the letters on one side of the equation, all of the numbers on the other side of the equation. Remember, you've solved the equation when you've got one of the unknown, in this case x, i.e. x, equal to a number. I think that one of the best places to start when doing a question like this is to consider where are there more x's. Now, I think the best place to start when looking at a question like this is to ask yourself, where are there more of the unknown? Where, in this case, are there more x's? Well, as we can see, there are 6 x's on this side and there are 2 x's on that side. So there's more x's on this side of the equation. So what we need to do is collect the x's where there are more x's. Okay, that saves you from ever needing to worry about multiplying or dividing by a negative number. It's going to always keep your unknown positive. Okay, so let's have a look at how we do that. Now I'm going to simplify this. 6x take away 2x is 4x. I've still got my negative 2 equals 1. I'm still looking at getting my numbers on one side and my unknowns on the other side. So now I've got no x's on this side, but I do have a number on this side. So I'm going to do the opposite, the inverse operation of subtracting 2. That's adding 2. Okay, now whatever we do to one side, we must do to the other side. The reason that we're doing that is because it's an equation. This is the same as this. So if I add an extra 2 onto this side, all of a sudden my equation isn't balanced anymore. So I need to make sure that if I add to one side, I add to the other side. Whatever I do to one side of the equation, I must do to the other side. That's how we keep it balanced. Minus 2 plus 2 is 0. That leaves us with 4x equals 1 plus 2 is 3. Now, how do I get x by itself? Well, this means 4 multiplied by x. So I do the inverse of multiplying by 4, which is dividing by 4. Whatever I do to one side, I must do to the other. 4 divided by 4 is 1. And my answer is 3 over 4, or 3/4. Okay, please do take note how I've worked my way down the page. Now, in an exam or a test, if you show you're working like this, even if you make a mistake at the end, you'll get marks for showing you're working. The last thing I want to look at is what happens when we have an equation that involves brackets. Now, this does depend on your ability to expand brackets. If you haven't done so already, it might be worth going and having a look at my expanding brackets video. So,